The next thing that concerns us will be limit at infinity. Okay, so the limit at infinity will be studied together with the horizontal asymptote. Let me point out something first. When we are talking about x at infinity, it means that you are consider x large. Okay, so it's going to be x large. Let me use x is large. Okay, so it's going to be x more than 10 to the 6, something like this. Okay, x is large. And if you are talking about negative infinity, it's not gonna call x is small. Okay, so this guy is called x is negative large. It's not that small, right? So it's gonna be x smaller than negative 10 to the 6 kind of. Okay, so this one is the place where we are talking about negative infinity and infinity. Okay, so this one is the case where we talking about infinity and negative infinity. So you're gonna see that, okay, so you're gonna see that if x decreases without an upper bound, then the value of the function f approaches 0. Okay, so you see that here, if you are follow this graph and the graph gonna go to negative infinity, x gonna go to negative infinity and the value of x turned out to be 0. Okay, and also in this case when x large, x go to positive infinity, the value of fx turned out to be very very small, so it's turned out to be 0 as well. If you consider this guy as a table, okay, so I told you before that the limit can be seen from table. So you see that if you have x and you have fx, if you have x equal to 10, fx will be 110. If you have x equal to 100, it's going to be 1 over 100. Let me write down in the decimal way. So it's going to be 0, 0 0.1, 0 0.01, and 1000 is going to be 0 0.001, and so on. Like 10 to the 16 is going to be 10 to the minus 16, which is very small. Okay, so this guy gonna tending to 0 when x large. Okay, so this one can be seen from the table. And also if you have x to be negative large, so if you have x to be negative 10, negative, 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 so you're gonna have negative, 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 and this guy will be small, but it's gonna be small negative. Okay, so it's gonna be negative of 10 to the negative 16 or something. Okay, so this one is negative large and positive large. We're going to use the notation in order to talk about negative large or positive large. When x go to negative infinity, it means that x decreasing without an upper bound. Okay, so you get limit x go to negative infinity, and you are talking about here, okay, negative infinity. And you have limit x go to positive infinity, or sometimes it's just infinity without any sign. It means you are talking about here. Okay, so this one limit x go to positive infinity and negative infinity give you the same value 0. So we may conclude that limit x go to infinity of 1 over x equal to 0, and limit x go to negative infinity of 1 over x equal to 0 as well. By the limit laws, we be able to just raise to the r power. So you raise to the r power, you have limit x go to infinity of 1 over x to the r turn out to be equal to 0, and limit x go to negative infinity of 1 over x to the r also equal to 0 for any positive r. Okay, for any positive r. Let me show you how to compute limit x go to infinity and negative infinity. Limit x go to positive infinity of 4x squared plus x minus 3 over 5x squared minus 2x. So in this case, this guy turned out to be limit x go to positive infinity, and you're gonna have 4x squared. Okay, so you see that you're not gonna factor this one as the previous technique. We're not gonna like factoring or plug in simplify. We not be able to plug in because x equal to infinity. When you plug in infinity into the function, you don't know how to compute for value. Okay, so in this case, you're gonna just for x squared, and the thing also that when you have infinity over infinity, this one is an indeterminate form. Indeterminate form, you're not allowed to like conclude anything from this form yet. You need to simplify, and normally we're going to simplify, and we are trying to use this relation that we have shown. So in this case, you have limit x go to positive infinity of 4x squared plus x minus 3 over 5x squared minus 2x. So in this case, you're gonna pull out x squared. Okay, so you have 4 plus 1 over x minus 3 over x squared. Let me use other color. So it's going to be you pull out x squared. So you get 4 plus 1 over x minus 3 over x squared. Okay. And on the bottom, if you pull out x squared, you would get 5 minus 2 over x. Okay, and you see that you get rid of x squared and x squared, and you are taking limit x go to infinity, right? So you are taking limit x go to infinity. This guy will approach 0 because it's 1 over x, and you have 1 over large. Okay, so this one is 1 over large like this, go to 0. Okay, and you have 3 over large, so this guy is also going to 0, going to be 0, and 2 over x here, you are going to 0. So in this case, you're gonna get 4 plus 0 minus 0 over 5 minus 0, and this guy will give you 4/5. Okay, so this one is how we obtain this limit. The second one, you have limit x go to positive infinity up to x squared plus 1 over x squared plus square root of x to the fourth minus x. Again, you're gonna try to do the same thing. You're not gonna get rid of the square root as usual. The thing that we're gonna do, we're gonna try to put into 1 over x to the r. So in this case, you're gonna pull the highest power out, and the highest power that you have here is the second power. So you see that you're gonna have limit x go to positive infinity, and you're gonna pull out x squared. So it's gonna be 2 plus 1 over x squared. Okay, and on the bottom you have x squared. Okay, and you have 1 plus, and you have x to the fourth minus x. Let me see x to the fourth minus x a little bit. You're going to pull out the highest power, which is x to the fourth. So it's going to be 1 minus 1 over x cubed. Okay, so it's going to be 1 over 1 minus x cubed. So this guy will be square root x square, and not square root x square root x to the fourth, and it's going to be square root 1 minus 1 over x cubed. And square root x to the fourth is x square. Okay, so in this case, this guy will be x square. So you pull out x square, so you get square root 1 minus 1 over x cubed. Okay, so this is how we do this question. Okay, so you see that you pull out x square and x square here. So you pull out the green guy from both terms, and this is what you end up with. And you're gonna get rid of x square on top and on the bottom, and you are taking the limit. So you are taking the limit x go to infinity. When you are having x go to infinity, this guy gonna be 0, and this guy gonna be 0 according to this relation. Okay, and in this case, you see that this limit turned out to be, so this limit turned out to be 2 plus 0 over 1 plus square root. Okay, so it's going to be 1 here. So it's going to be 1 plus square root. So it's going to be 1 plus square root 1 minus 0. Okay, so in this case, it's going to be 2 over 2 equal to 1. Okay, so this is how we have this limit. The next one is limit x go to positive infinity of sine x over x. So in this case, if you try to plug in, you're going to get something funny. So you're going to get sine infinity over infinity. And sine infinity over infinity, you not be able to conclude for value for this guy. Okay. In order to deal with this guy, it's going to be that you need constant over infinity. If you have constant over infinity, this guy turned out to be 0. And this one is nice. Okay, so if you have constant over infinity, it's going to turn out to be equal to 0. However, you not be able to control sine infinity yet. The thing that you can obtain constant will be you're going to play with this sine like we have for the squeeze theorem. We learned that sine x lie between negative 1 and 1. Okay, so we learned that sine x lie between negative 1 and 1. And you like to have sine x over x, so you're going to divide by x. Okay, for the whole thing like this. And you are having limit x go to positive infinity of negative 1 over x equal to 0, and limit x go to positive infinity of 1 over x also equal to 0. So this one is the thing that we have seen for squeeze theorem. So you have the top and the bottom function. Okay, you have the top function is 1 over x. You have the bottom function is negative 1 over x. So in this case, you'll be able to conclude that you have the limit of the middle guy. So you have limit x go to positive infinity of sine x over x. Okay, so this one is the pink one, sine x over x, turn out to be equal to 0, okay, by squeeze theorem. Okay, so that's all. So this one is not that difficult to do. Another one will be limit x go to positive infinity of square root x squared plus 4 minus x. Okay, so if you like to compute this limit, you're gonna try to simplify this one in order to obtain something over x. So you need constant over infinity. Your target will be constant over infinity. In this case, you not see anything that you have on the bottom yet. So in this case, we're gonna multiply something on the bottom. The thing that we're gonna multiply turned out to be the thing that used to simplify the term. Okay, so what is the term that I used to do before? The thing that I used to simplify the term before is the thing that I be able to get rid of square root. So you have square root x square plus 4 plus x on top, and you have square root x square plus 4 plus x on the bottom, like this. And when you multiply this one, you see that you get x square plus 4 minus x square, and you have x square plus 4 square root plus x. And you see that this one is very nice because after you have this limit, so it's going to be limit x go to positive infinity. So you allow yourself to get rid of x square and negative x square. Okay, so it's not quite clear. Let me, so x square and negative x square. So it's going to be 4 over square root x square plus 4 plus x. And you have x go to infinity. So this guy will be 4 over infinity. Okay, so it's going to turn out to be 4 over infinity. And 4 over infinity turn out to be equal to 0. Okay, why 4 over infinity is 0? Because this guy is constant over infinity. How would I have infinity is come from here. So when you plug in infinity, so you get infinity plus 4 square root plus infinity. And you see that infinity plus infinity is just infinity because infinity is already large. Double it turn out to be larger, but you cannot have something larger than infinity. So it's going to be just infinity. Okay, so that one will be your infinity plus infinity. However, if you have infinity minus infinity, okay, I'm going to say however. However, when you have infinity minus infinity, this guy turned out to be an indeterminate form. Okay, so that you not be able to conclude for value yet. You may have to simplify the term first. For the last question for this topic, it's going to be limit x go to negative infinity of 2x minus 3 over square root x squared plus 10. Okay, so you like to find limit x go to negative infinity. So for this one, we're gonna play with the same thing. So you're gonna try to pull out x. So it's gonna be 2 minus 3 over x. Okay, this is the normal thing to do. and you have square root, and you're gonna try to pull out x square. So you have 1 plus 10 over x square. Okay, and you see that this guy will be x 2 minus 3 over x, and you're gonna have this over square root x square square root 1 plus 10 over x square. Okay, so this is what it look like. However, if you have x and 2 plus 3 over x, and this guy is over, square root x squared turn out to be absolute x. Okay, square root of x squared turn out to be absolute value of x, and this guy is square root 1 plus 10 over x. Okay, and you see that you not be able to get rid of x and absolute value of x like I mentioned earlier. However, you have to see the behavior of your function. So you would want to find the limit x go to negative infinity. Okay, so you want to find the limit x go to negative infinity. Let's do that. So you need limit x go to negative infinity of this guy. Okay, so of this guy, let me copy the whole thing so I don't need to write. So you get this term, okay, limit x go to infinity, and you see that when you are having x go to negative infinity, you have to know where you are at. So you have 0 in the middle. Okay, so you have the y in the middle, you have x. Negative infinity is here, 0 is here, and positive infinity is on that side. So when you have negative infinity, you are on this side, and you are on the side that x less than 0. Okay, so you have x less than 0. So absolute value of x turned out to be equal to negative of x. Okay, so this is what it means for being going to negative infinity. So in this case, x here and negative x here will cancel each other. So you end up with limit x go to negative infinity of 2 plus 3 over x over square root 1 plus 10 over x. And you are having x going to negative infinity. So this guy will approach 0, and this guy will also approach 0. Okay, so in this case, the limit turned out to be 2, and you don't forget the negative side here on the bottom, so it's going to be negative 2. Okay, so this limit turned out to be equal to, let me write in this way, so it's going to be 2, and you're going to have negative 1, so it's going to be negative 2. Okay, and you have limit x go to infinity. So you have limit x go to positive infinity. Okay, so let's do limit x go to positive infinity of this term. Okay, so let's do x go to negative infinity. If you are having x go to positive infinity, it means that you are on this side. Okay, so it means that you are on this side, positive infinity. And for this guy, you're gonna have limit x go to positive infinity. And you see that when you have x go to positive infinity, it means you have x positive. So it's more than 0. So you have x more than 0 here. So the absolute value turn out to be x. Okay. So in this case, you're gonna have x, okay, and you have square root 1 plus 10 over x, okay, and you have x 2 plus 3 over x, okay, and you're gonna have x and x cancel each other nicely, and you're gonna have this 3 over x approach 0, and 10 over x approach 0. So in this case, you're gonna have 2 over 1, and it's gonna be equal to 2. Okay, so you see that you have limit x go to negative infinity equal to negative 2, limit x go to positive infinity equal to 2. By the way, we don't have, let me emphasize on this one. I saw some of you do this. The thing that we don't have will be, we don't have limit x go to infinity from the left like this one, and we don't have limit x go to infinity from the right, something like this. We don't have it. Okay, you have to take a look here that, hey, negative is in front of, positive is in front of. It's not superscript. Okay, so we don't have these two guys, not be confused. Okay, so we don't have them. Okay, we have limit x go to negative infinity and limit x go to positive infinity. This will allow you to conclude about the horizontal asymptote. So this one is horizontal asymptote. What does it mean for to be horizontal asymptote? It's gonna be the horizontal line that the graph gonna tend to when x large or when x negative large. Okay, so for example, if you see that limit x go to positive infinity equal to 4/5, this guy, what does it mean? It means that if you graph this one like this, xy, so it means that when x go to positive infinity, when x go to positive infinity, the graph of the function turned out to be going to 4/5. Okay, 4/5 is here, and the graph of the function gonna go to this one. Okay, so this one is the meaning of this guy, and this guy will turn out to be horizontal asymptote. Okay, so it's going to be horizontal asymptote. For this one, you see that limit x go to positive negative infinity. Let me draw a graph for you. So if you graph this guy, okay, so you have your y, you have your y, and you have your x. Okay, you have your y and you have your x. So in this case, when x go to positive infinity, okay, so when x go to positive infinity, which is here, and negative infinity, which is here, you see that x go to positive infinity, you're gonna have the limit equal to 2. Okay, so the limit will be equal to 2. So the graph will look like, okay, so you're gonna have horizontal line like this one. This one is y equal to 2, and your graph will tend to this line. Okay, horizontal asymptote. And for y equal to, for x equal to negative infinity, so you're gonna get this one. okay, and you're gonna see that your graph gonna tend to this line, okay. So this one is y equal to -2, and both of them in this case are horizontal asymptote. Okay, so that's all I need to teach you here. Okay, so let's conclude. What did we learn in this script? It's gonna be about determining infinite limit. So you have limit x go to positive infinity and limit x go to negative infinity, and they will give you two horizontal asymptote or maybe one horizontal asymptote depending on the situation of the function. Okay, and the way to determine this limit turned out to be we try to obtain 10 over x, 3 over x like this. It's not by factoring. However, it's going to be by pulling out the highest power of x from the function. And that will allow you to get 0, 0 for many terms, and you'll be able to conclude the limit. Okay, so the technique in this section is not factoring. However, it's going to be pulling out the highest power of x instead. Okay, so this is all of the thing that I complete this one. We're going to have only the last section is how to determine the infinite limit, and we're going to finish this chapter 2. Okay, so that's all I like you to know today. Okay, thank you.